Hello and welcome to Algebra 2 tutorial. We are still looking at transformations of quadratic functions. What we've done so far are all these here at the top. We've done reflections, we've done vertical and horizontal translations, those are the slides, and we've done some vertical stretches and shrinks. So now it's time to add one more, the horizontal stretch and shrink. So, again, we're going to be taking a look at three different modes here. A description, a graph, and an equation. You want to make sure you can go between all three of those. With the horizontal stretch and shrink, it's a little harder to do the graph, so oftentimes you'll just do a rough sketch, but we will take a look at that some. So first, what is the horizontal stretch and shrink? So the one that we are already familiar with is this one, the vertical stretch and shrink. That's if your A is on the outside. Now the A is moving on the inside. That gives us a horizontal stretch or shrink. But you can see that there are some similarities. We use the same letter, A. And so you're going to definitely see some similarities in how these two work, but there are some very important differences as well. So to do that, let's take a visual approach. So here we have our parabola. We can move it side to side, up and down, with our h and our k. But I've also got two a values in this. I've got an a on the outside and an a on the inside. And so we want to take a look at what those two do. So first, this is the a on the inside. This is a horizontal stretch and shrink. So imagine what's happening horizontally. We shrink it down, and we stretch it out horizontally. Now let's take a look at vertically. This is the A on the outside. That is actually a stretch, and that is a shrink. We've done that one already. But hopefully you're seeing they look very similar, and they do have some similarities. Just the difference is how we describe them right now. So this is a horizontal shrink because the point here, oops, I got it here. The point here was shrunk in horizontally, and we're only thinking horizontally. So this here was pulled in. This point here was pulled in. But if we think about this vertically, it then becomes a stretch. So the point here was pulled up vertically to there. So a vertical stretch and a horizontal shrink look very similar. And if you're going to describe one way or the other, you either have to think vertically or horizontally. And just look at them whatever way you need to describe this. So now a little bit more technical things with the numbers. Let's put everything back to 1, back to our parent function. So let's do the one we know, the vertical. So if we make the a value bigger, that is a vertical stretch. The points go from here, and to go vertically, I have to go up. It was stretched up. That's for bigger numbers. If we make the numbers smaller, less than 1, you can see now we have a vertical shrink. The graph was pulled down towards the x-axis. So if a is bigger than 1, we have a stretch vertically, and if a is less than 1, we have a vertical shrink. We knew that already. Now it's time for the one we don't know. The horizontal. So now we're thinking horizontally. So if I make a bigger than 1, you can see that we now have a horizontal shrink. It's being brought in towards the y-axis. And if I make a less than 1, we are being stretched out. And that's a little counterintuitive. When a gets smaller, we have a stretch. When a gets bigger, we have a horizontal shrink. So again, things that are on the inside are counterintuitive. The H was backwards, and now the A is also backwards. A bigger number means shrink, and a smaller number means stretch. We're thinking horizontally now. So let's go back and write that down. So the first one, when we are thinking vertically, things happen the way we want them to. If A is bigger than 1, we have a vertical stretch. And if A is less than 1, we have a vertical shrink. When we talk horizontally, that all gets flipped. If this A is greater than 1, we have a horizontal shrink. And if A is less than 1, we have a horizontal stretch. Now, when I say less than 1, I am not thinking about negatives. Negatives do something else, so technically I should put the absolute value. You don't need to worry about that too much on that, but to be mathematically precise, I should put that on there. Any decimals or numbers where the absolute value is less than 1 will cause the horizontal stretch or the vertical shrink. All right, so we got a little bit of visual. Let's actually do a few numerical examples now, okay? So, we're going to be trying to do descriptions, equations, and graphs here. So we're going to start with descriptions here. I've got the equation. Let's write a description of what is happening. So, f of x is equal to, on the inside we have 3x squared plus 4. So this 3 on the inside is going to be a horizontal stretch or shrink. So we identify that first. Then we think, all right, it's a 3. That number is bigger than 1, so that is going to be a horizontal shrink. All right. F of x has a horizontal shrink and whenever we do a shrink or a stretch, we do it by a factor. By a factor of... Now here's where it gets a little confusing. And there's two numbers here that I'm kind of okay with. If you say it's a shrink by a factor of 3, I think that makes perfect sense. I think most people would understand what you are talking about. But there are a lot of people that also believe you should say not 3, because the big number makes you think bigger things. It makes you think stretch. So a lot of people want you to turn that into a fraction and say that is a horizontal shrink by a factor of 1/3. I'm kind of okay with both. I think linguistically they are both clear, personally, as long as you have this word here, shrink. Don't want to forget the other transformation here. We were also translated up 4, so we should also put in and translated up 4. All right, so we described that equation. Let's see if we can now describe a graph down here. So if I take a look at this parabola here, it looks to me like it's too wide, like it has been stretched out that way. And we can check it. The pattern for a parabola should be over 1, up 1, over 1, up 3, over 1, up 5, etc., etc. So it should be somewhere in here. And yes, it has been stretched out horizontally. So this has a horizontal stretch. Now, oftentimes for the graph, that's as far as you can go unless you get lucky and you can count a little bit for what that stretch actually is. And I gave us an easy one here so we can. So I can actually figure out by a factor, of, so how much? I was supposed to go over 1, up 1. How long did it take me to get up to this same height? All the way over here. So that went out 1, 2, 3. And how long does it take you to get up to this point right here? Instead of over 1, it's over another 1, 2, 3. So instead of going over 1 each time, we're having to go over 3. So we are being stretched by a factor of 3. And we, of course, have a translation down. Those are the easy ones. By 2. Now let's write that equation. It's good practice for us. So because we have a horizontal stretch, we're going to have a number on the inside with our x, and then translated down means we have that minus 2. Let's do the easy stuff. Now what number goes on the inside? I cannot put a 3 right here. If I put a 3 there, that would be a horizontal shrink. We have a stretch. So to make that work, this has to be a number smaller than 1. It's actually the fraction 1/3. That gives you a horizontal stretch by a factor of 3. All right. One more set of examples here for us. We were working with descriptions. We're now going to work with some more equations. That fraction thing is kind of difficult, so let's take a look at that and do that just a little bit more and practice writing an equation. So a parabola has been horizontally shrunk, I guess that's a word, by a factor of 5 and translated down 8. So y equals, we're going to have some numbers on the inside. I'm going to do the easy part first. Translating down 8 is just a minus 8 on the outside. Do the easy stuff first. But now the horizontal shrink. So if I'm going to shrink by a factor of 5, that's a big number. Remember, numbers bigger than 1 make a shrink. So I'm going to use that 5 right here. It's larger than 1. That tells me a shrink. That's exactly what I want. And so the 5 just goes right in there. All right, graphically, let's take a look at this one. I think this one is a stretch again. So over 1, up 1, over 1, up 1, 2, 3. Yeah, this one has been stretched out, been pulled out to there, pulled out to there. So this is a stretch. So that means this number on the inside of our equation has to be smaller than 1. It's also been pulled down 2. I'm going to do the easy part first. That would be a minus 2 on the outside. So what number goes on the inside? Sometimes you can't figure this out, but this one is nice and easy, so we can. Instead of going over 1, up 1 to get to this point, we had to go all the way out to here, which is over 2. So it's been stretched out by a factor of 2. But we don't put the 2 here. Because remember, a number bigger than 1 means a shrink, and we need to stretch. So we turn that 2 into a fraction, 1/2. All right, that's a little equation practice for us. It's a little difficult from a graph. Mainly you want to be able to do it from a description. A bigger number means shrink, and a smaller fraction means stretch. All right, I think that gives us some pretty good examples for how that goes. So now I want you to try a few practice problems. And if you've got those, you're doing pretty well. Good luck.